Assalamualaikum. My name is Ahmad Azim bin Zulkifli. My metric number is D202211045889.
Hello, my name is Irshad bin Razali. My metric number is D202211033743.
Hello, my name is Carl Christine. D2211033735.
Bismillahirrahmanirrahim. My name is Muhammad Mukhrish Aiman bin Ahmad Bakri. My metric number is D202211033760.
Bismillahirrahmanirrahim. My name is Muhammad Aziz Aiman bin Muhammad Noor. My metric number is D202211033759.
Before we move to question, we do some recap. Okay, for tangent planes, this tangent plane we use for to approximate a function of two variables, and linear approximation we use to make an otherwise calculation possible to get a low chance about lack of accuracy. Okay, we move to the formula. This is a formula for tangent plane where z minus to z naught equal to f function x naught y naught multiply with x minus x naught plus function y x naught y naught multiply with y minus y naught. Okay, this is a function for tangent plane, formula for tangent plane, sorry. And then linear approximation where f function xy equal to function ab plus dengan function x ab multiply with x minus a plus f function y ab multiply with y minus b. Okay, next to linearization formula where L stands for linear, xy equal to f ab plus fx ab multiply with x minus a and plus fy ab multiply with y minus b. Okay, for the last formula for this subtopic is differential. Differential d z equal to fx xy dx plus fy xy f function y, this one is function x, function y xy dy equal to dz over dx plus dz over dy. That's all formula we got for this subtopic. Thank you.
For the first question is find the tangent plane to the elliptical parabola z equal to 2x squared plus y squared. That's the equation. And at the point 2, 2, 6. Okay, now for the first step, we need to let function xy equal to 2x squared plus y squared. And we need to find the partial derivative and evaluate at point 2, 2, 6. For the first step, for the function x, after we find the partial derivative, so we got 4x, and we evaluate at the point 2 and 2, so we got 8. For function y, after we find the partial derivative, so we got 2y, and we insert the point at 2, 2, so we got 4. Okay, using the formula of tangent plane, we insert the number we got, so z minus 6 equal to 8 multiply with x minus 2 plus 4 multiply with y minus 2. So from the general equation, we simplify. We got z minus 6 equal to 8x minus 16 plus 4y minus 8, and we got the more simplified z equal to 8x plus 4y minus 18. So this is the answer for this question. For now, we want to see how we got the mark. So for 2 marks we got here after we find the partial derivative and we evaluate at the point. So this is first mark. So for the second mark we got here after we find the partial derivative for y and we insert the point. So we got more another 1 mark. So for the 2 marks we got here after we insert the point to the general equation, and another mark we got here after we simplify the general equation. So this is for question 1.
Okay, Bismillahirrahmanirrahim. So we move to the next question, is question number 2. Okay, question given is, given the function f x y equals to x squared x power of 2 y plus y cube. Find the equation of the tangent plane to the surface at the point P1, 2. Then use the tangent plane to approximate the value of f 1.1, 1.1 and 1.9. Sorry. Okay. So how to answer this question? So first, the first step is you need to find the partial derivative and evaluate at point P1 and 2. Okay. So when you do this part, you got 2 marks. So you need to fx xy equals to 2xy for the x part, and for the y part is x equals to x power of 2 plus 3y squared. Okay. How we got this from the equation? From this equation, for x part we just took the x part only, x squared and y, and we differentiate this. Okay. So the y part we took that 2. Okay. So we just substitute the point 1 and 2 into the x1, x is equal to 1 and y is equal to 2. So the x part we got 4 and the y part we got 13. So when you do this, you get 1 marks and 1 marks. Okay, 2 marks. Let's go to the next step is find f1 or 2. So f x y. So with this we got from the equation from the question. So we just substitute the value 1 2 into the equation. 1 square multiply with 2 plus 2 power of 3, and we got 10. So this will provide 1 mark only. Okay, we go to the next step to find equation of the tangent plane. So the formula of the tangent plane is z equals to f a b. This is from equation, and this plus fx a b x minus a we have, b we have. So fy a b we have to do it previous just now. Okay. So we just substitute z equals to 10 plus 4. 4 is 4. X plus x minus 1. A is 1. So b is 2. So 13 fy a b 13. We get this from the previous calculation. Okay. So we simplify it. We get z equals to 4x plus 13y minus 20. So this will provide you 1 mark only. Okay. So the last step is approximation of f 1.1 and 1.9. So using the equation before just now, z equals to 4x plus 13y minus 20. So this is the symbol of approximation, and we just substitute the value into the equation, x and y. X is 1.1 and y is 1.9. So we got the final answer is 9.1. Okay. So the mark is 1 mark, and the total mark of this question is 5 marks only. So thank you.
Okay, for the next question, we have approximate function 507 using point 2 and y, where function xy is equal to exponent power 5 minus 2x plus 3y. In this question, we need to compute the first one, where we need to find function 2, 1 equal to y. So, using the equation that we have, we just insert 2 in x and 1 in y, and we will get exponent 4. Next, for the compute partial derivative, function x and function y, this will give you 2 marks, which is we need to partial derivative the equation, and we get negative 2 exponent 5 minus 2x plus 3y, while the fy we derivative it and become 3 exponent 5 minus 2x plus 3y. We just need to substitute x and y with 2 and 1, and we will get negative 2 exponent 4 for function x, and fy we will get 3 exponent power of 4. Next, the third step is we need to set up the linear approximation formula. This is the linear approximation formula: fab plus fx ab x minus a plus fy ab y minus b. We need to substitute a equal to 2 and b equal to 1, where at the end we will get fx is negative 2 exponent power of 4 and fy is 3 exponent power of 4. The linear exponential formula that we get at the end is Lxy equal to exponent 4 plus negative 2 exponent 4 multiplied by x minus 2 plus 3 exponent power 4 and y negative minus 1. So we need to simplify it, and it will become exponent 4 minus 2 exponent 4 multiplied by x negative 2 plus 3 exponent 4 multiplied by y minus 1. The next step is for the 2 marks is we just need to substitute x and y with 5, 0 and 7 into our linear expression that we just solved up front, where at the end we will get is this one is simplify the equation, and we will get the final result is exponent 4 minus 6 exponent 4 minus 0.9 exponent 4 equal to exponent 4 multiplied by negative 5.9.
So we go to the next question about the daily life application. Okay, first, the question: the radius and height of the cylindrical container are measured as 5 cm and 20 cm. Okay, we got the first hint, and respectively with error of 0.05 cm. Okay, this is the second hint we got in each measurement. Use differential to estimate the maximum error in the calculated volume of the cylinder. Okay, first, as we know, if you write the formula for cylinder, the volume of cylinder, V is equal to pi r squared h, you got 1 mark. Okay, and then after you write the formula, you need to differentiate it. So dV is, we use the formula dV is equal to dV per dr multiplied by dr plus dV per dh multiplied by dh is equal to 2 pi r h multiplied by dr plus pi r square dh. We differentiate this for dV dr, and this is for dV dh. Okay, and then we substitute the given value of r, h, dr and dh. If you substitute, you got 1 mark. So from the question, we got r is equal to 5, h equal to 20, and from the question also, we got the dr and dh is also 0.05. So we evaluate the number into the differential equation that we got from the upside. So we got the 2 pi multiplied by 5 multiplied by 20 multiplied 0.05 and plus 2 pi multiplied by 5 power of 2 multiplied by 0.05. So we got the 10 pi plus 1.25 pi. So the final answer we got is 11.25 pi, and then the approximation of the maximum error is 35.34 centimeter cube. So after that, you make the conclusion for the question that you got. Okay, so the estimated maximum error in the calculated volume of the cylinder is approximately 35.34 centimeter cube. So the total mark for this question is 6 marks. If you do all the step by step, you from the formula to the calculation, so you get 6 mark full mark. Okay, thank you.